There's a revolution happening in medicine right now, and it's probably not what you're picturing. It's not happening in a lab with test tubes, it's happening inside computer servers, and it is completely changing how we fight our toughest, most persistent diseases, things like cancer and heart failure. It all starts with something that looks pretty familiar, a medical scan. Now, to you and me, it's just a complex, grayscale picture. But to a computer, it's something else entirely. It's a treasure trove of data, with millions and millions of tiny points of information all hidden in plain sight. So, just how much data are we really talking about? Well, a single high-resolution scan for one patient can be over 300 megabytes. That is just packed with information describing the density and structure of our tissues. And here, this is the part that is just incredible. A properly trained artificial intelligence can analyze all those millions of data points, pick out suspicious patterns, and tell you the probability of cancer in moments. It's like having a diagnostic superpower. That's the big question, right? How can a machine learn to see disease in a way that can rival and sometimes even beat a human expert? Well, the answer isn't magic. It's what happens when you combine two of the most powerful technologies of our time, the enormous scale of big data and the incredible pattern-finding ability of artificial intelligence. So let's break down what that actually means. First things first, let's talk about the fuel that makes this whole thing go. Big data. What is it really? The simplest way to think about it is like this. If a file is so huge or so complicated that you literally can't open it on your laptop, you're probably dealing with big data. We're talking about information on a scale that just requires massive, massive processing power. But big data isn't just about size. Experts usually define it by what they call the 4 V's. You've got volume, which is the massive scale; velocity, the crazy speed at which data is created and moves; variety, meaning it comes in all forms, images, text, genetic code, you name it; and finally, veracity, which is all about the challenge of making sure that all this complex data is actually accurate and trustworthy. Okay, so if big data is the fuel, artificial intelligence is the engine. But how do you actually teach a machine to turn all that raw information into life-saving insights? First, we have the big overarching idea, artificial intelligence. This is the grand goal, right? To build machines that can actually simulate human thinking, reasoning, and decision-making. But the practical tool we use to get there is machine learning. This is the how-to. It's the specific algorithm, the technique that we use to feed a machine a massive amount of data and basically train it to find patterns and make predictions all by itself. And the process is actually pretty logical when you break it down. You start with raw data, say thousands of medical scans, each one labeled by an expert as either healthy or diseased. Then you clean it all up. And then comes the crucial step. You feed this clean data to a machine learning model. It just churns through it, learning to connect certain patterns with a diagnosis. And finally, once it gets good enough, you deploy it. Now, here's a really key difference from how we've traditionally used data. A statistician, they're trying to understand the relationship between things, the why. But a machine learning model, it's obsessed with just one thing, making the most accurate prediction possible. It lets the data itself reveal the patterns, often in ways a human would never, ever see. So what do you get when you combine these massive data sets with predictive machine learning? Well, you get a completely new arsenal in the fight against non-communicable diseases. And some of the applications are just stunning. Take a look at this number, 826 million. What on earth could that be? It's not patient records, it's not medical scans, it's tweets. And this is just a brilliant example of using unconventional data. By analyzing the language, things like stress and anger, in millions of tweets, and then combining that with public health data, researchers built a model that could actually predict death rates from heart disease at the county level. Just amazing. And the data sources get even more creative. We are now looking so far beyond the hospital for clues about our health. We're even looking down from space. In another incredible study, researchers used satellite data, specifically looking at the health of the vegetation in different areas, to map and predict where childhood stunting was most likely to occur in Nigeria. They were able to link environmental data directly to a major public health crisis. And this toolkit is just getting bigger every single day. We've got scientists combining genetic data with health records to predict liver disease. AI models are diagnosing complex eye diseases from retinal scans faster than a whole team of experts. And systems like IBM Watson, after reading something like 15 million pages of medical text, are now helping doctors recommend personalized cancer treatments. Now, it is so easy to hear all this and think, okay, the AI doctor is here to replace the human one. But the reality is way more nuanced, and frankly, it's a lot more interesting than that. With all of this incredible predictive power, a really critical question comes up. Can we just hand over the reins? Can we fully trust these algorithms with what are literally life or death decisions? Well, a fascinating study from 2023 gave us a pretty serious reality check. Researchers used a powerful AI to help write a scientific paper, and they found something startling. When they asked the AI for its sources, the AI just made them up. It confidently invented citations that sounded completely plausible, but were totally fake. And this gets to the absolute heart of the matter. An AI doesn't know what's true. It only knows what patterns are statistically likely. This makes it an unbelievably powerful partner for finding that needle in the haystack, but it is not a replacement for human expertise. We need doctors for validation, for context, and for critical oversight. So this revolution, it isn't really about replacement. It's about partnership. The AI doctor is already in the room, analyzing data in ways we never could before. So the question for us now isn't if we'll use it, but how we learn to work alongside it, combining its raw computational power with our own human wisdom. The real question is, are we ready?